Hi and welcome to JavaScript closures. I want to start with some basic terminology. So what is a closure? A closure is a combination of a function object and a scope in which the function variables are resolved. JavaScript is a lexical language. What does this mean? It means that a language that it is lexical, it uses lexical scoping. What it means is that when a function gets executed, it will use the variable scope that was in effect when the function was defined. Reviewing variable scope. Variable scope is the region of code in which a variable is defined. A scope chain is very important in closures. The scope chain is a list of or a chain of objects that defines the variable that are in the scope for that code. Variable resolution is a process of JavaScript looking up the value of a certain variable. So let's start with some basic examples that I have already prepared. So basically, closure.html refers to the JavaScripts defined on the left. Example 1 refers to example1.js. Example 2 refers to example2.js, and like that. I have defined already 9 examples. So let's start with example number 1. Example number 1. So basically, to start with, closures define an inner function that basically has a longer lifetime than the outer function. And a closure is basically, let's look at say hello. What is say hello doing? Say hello is a function that is defining some local variables, and to the variable say alert is actually assigning a function to it and then returning that variable. So what this is actually doing on say equals say hello team, you're passing the value team to say hello. Say hello is the outer function, and the outer function is actually assigning the result of invoking the outer function. The function returns an object containing exactly one method. The method, it is the function that it was assigned to say alert. So, and after that we are calling say, the object say. The object say holds the function object that was returned by say hello. So let's see the output of this. We see that it outputs hello team. You're passing team, it gets assigned to, it gets concatenated with hello, it gets assigned to text, and then when you call say, it's gonna go to the inner function and then put that in the console. So now let's go to example number 2. Example number 2 is very similar to example number 1. The basic difference is that I want to show how to call say the say hello function in a different way. So you can basically append a second set of parentheses where you can actually this is one way of calling that function. The outer function, this is another way of calling the outer function with a second set of parentheses. So if we look at the output, we say that it outputs hello Bob as you're passing the value Bob. So example number 3, let's say that you define this function called say123. It is assigning the value to num. You are creating this inner function, assigning to say alert, incrementing the value of num, and then returning say alert. So this is basically the same idea as say hello. So you call it with 2 sets of parentheses. So let's just see the output of this. 124. This is a very simple example. Example number 4. Example number 4, it is actually defining 3 different inner functions. For example, you start by creating variable c. You assign the value returned by set of some globals. So set of some globals is returning a function object. So now that you have a handle on the object, you start calling the inner function. So you start with alert number, increase number, and set number. So what you expect to see is you're gonna increment the number and then you're gonna reset it. So let's see the output from this example. So you alert the number 666, you increase the number 667, and then reset it back to 666. So this is another way to define, well, actually to access the properties defined for this object called C. So now C has three different properties: alert number, increase number, and set number. So now let's look at example number 5. Example number 5 is, it has a function called fade. You're passing document.body to fade. Fade sets the level to 1. It defines as a step function, and it calls set timeout. It is passing a step function and a time 100 milliseconds. It then returns, and fade has already completed. So this is very interesting because the inner function has a longer lifetime than the outer function. So after a while later, the step function gets invoked again. It makes a base 16 character from fade's level. It then modifies the background color until it gradually changes to white. It looks at the fade's level. If it hasn't gotten to white yet, it then increments fade's level and uses timeout to schedule itself to run again. Suddenly the step function gets invoked again, but this time fade's level is 2. Fade returned a while ago, but these variables continue to live as long as they are needed by one or more of fade's inner functions. It is important to understand that the inner function has access to the actual variables of the outer functions and not copies. So let's look at the output of example number 5. It starts with yellow. It gradually increases fade's level until it reaches white. Let's look at example number 6. Example number 6 is very similar to the say hello examples, and this is basically just to show that the variable Alice, it is declared after the function it is defined. The inner function, it is using Alice, the values of Alice. Alice is defined or declared after that function, but it doesn't really matter because the variable scope, what's most important is that it is looking at the variable scope. So let's look at example number 6. Example number 6 is only to show that the inner function is using the value of Alice. The variable Alice is defined after that inner function, but that doesn't really matter. As long as that function is defined inside the outer function, it will have access to that variable. So this is also another way to call the outer function. So let's see the output of example number 6. It will go and retrieve hello Alice. This is example number 7. Example number 7, it is actually declaring an object and is defining a function and invoking that function right after, as you can see by in code line number 13 by the set of parentheses there. It's actually returning a function object containing exactly 2 methods: increment and get value. So for example, once you declare the variable my object, you can call the methods defined for that object. My object.increment, it will increment the value of the value variable to 5, and then we will output that value, and you would see. So this is example number 7. So this returns 5. Every time returns 5. So it is for the increment, it is checking the type of increment. If it is a number, it increments value by that amount, otherwise it increments by 1, and get value is basically a get function for that value. Let's look at example number 8. So example number 8 is basically a way to emulate private functions using closures. So it is for the variable counter is assigning a function to it and then calling it. So this what is actually returning, it is returning a function object with 3 public function, and it also has 1 private function. So that the counter object is already defined. So once you call value, it will print 0, and you increment twice. You call value again, it will print the value 2. And then you can also decrement. And the point of this example is that you can define public members, public functions, and private methods. Actually, public methods and private methods. Private methods get called by the public methods, by which you can change or read private data, just like in Java. So, for example, the output of example number 8, it would be 0, 2, and 1. Let's look at an interesting example. This is example number 9. So down here I have a commented code. This is when you declare closures inside a for loop. So for example, what you expect that is going to print is that it's going to print for example from 0 to 2, 0, 1, 2. The inner function is defined inside the for loop, so that's what you expect, that the variable I is going to be passed every time, but that's not actually the case. So what you actually want to do is you want to avoid creating functions within a loop, because it can be wasteful computationally. It can cause confusion. So to avoid the confusion, we do it by creating a helper function outside of the loop that would deliver a function that binds to the current value of I. So if we run example number 9, we see that it prints as expected 0, 1, and 2. So this is it for today. Thank you very much. Hi and welcome. This is JavaScript. We're going to be talking about variable scope. So let's start with some basic terms. So variable scope. Variables declared within a function are defined only within the body of the function and are called local variables and have local scope. Local variables take precedence over a global variable with the same name. You must always use the var keyword to declare local variables. Each function definition has its own local scope. That allows nested scope. Global variables are defined everywhere in the JavaScript code and they have global scope. JavaScript has function scope as opposed to block scope. What does this mean? It means that JavaScript, the parameters and variables in a function are not visible outside of the function, and also a variable defined anywhere within a function is visible everywhere within the function. It is best to declare all the variables using a function at the top of the function body. Global variables are properties of the global object. If you use the var keyword, the property created is non-configurable, which means that cannot be deleted using the delete operator. If you assign a value to an undeclared variable, JavaScript automatically creates a global variable. The this keyword is used to refer to the global object. Local variables can be imagined as the properties of an object associated with each function invocation. So let's start with some examples that I have prepared. So I have the scope.html with 8 examples. The JavaScript code is on the left, and it is loading the script scope.js and scope2.js. So let's start with example number 1. So let's focus on example number 1. It is basically just printing the value of the variable a. We created a global variable a with the value of 1. So let's see the output of 1. So we see that the output is 1. It's using the global scope from variable a. So now let's focus on example number 2. Example number 2 has a parameter called a, the same name as the global variable a. So let's see, what does that print? It prints 5. I was calling example number 2, passing the value of 5. So the parameter it is using the value of 5 to create a local variable called a, which has the value of 5. Example number 3, it is an example of local scope. When you call on example number 3, it creates a local variable called a with the value of 3. Let's see what does that print out. Prints the value of 3. So example number 4, it focuses on the concept that JavaScript does not have block scope, like for example C, in which for example in the if statement the local variable would exist only within the curly braces of the if statement. In JavaScript that is not the case. So for example here, when you create the variable local variable a within the if statement, is going to be existing after you exit the if statement. So let's see just the output from example number 4. The output is 4. So let's focus now on example number 5. Example number 5, it talks about variables as properties. So when you use the var keyword, it's going to create a non-deletable property of the global object. If you don't use the var keyword, you actually create deletable properties. So for example, in true var it creates it appends this property to the global object, and is not deletable. If you use the delete keyword, it will not succeed in deleting it. If you create fake var and fake var 2, these are deletable properties. If you try to delete them, they will be deleted. So let's see the output of that. This is example number 5. So false, true, true. So false, the first one, delete true var. True var, it is false. It was not successful in deleting it. Delete fake var, it was true. It was successful deleting it. And fake var 2, successful deleting it. So now let's go for example number 6. I create a global variable called scope with the string global scope. So let's see example number 6. It is calling local scope. Let's see just the example of that output from that example. It will print out local. It returns variable scope local as opposed to the global scope. So example number 7, let's see example number 7. So this function, it is also called local scope. It has a variable called scope and my scope, but it's not using the keyword var. That's very important. It's going to create global variables. So when you create global variables and you have another one that is called the scope, is going to overwrite that one, and it's going to create another global variable called my scope. So when it is returning this, the value of scope is local, the value of my scope is also local. So as you print out scope and my scope, you can see the values local and local. So this is example number 8. This is an example about nested scope. So again, a function called local scope creates a variable called scope with the value local scope, and it has a nested function called nested scope. So when you call on local scope, it's going to go and define this function, and it's going to return nested scope. So basically each layer within the function creates its own local scope, so this is going to return nested scope. So that is it for today. Thank you very much.
Hi and welcome. This is function objects. Let's start with some basic terms. Functions are objects, which themselves are collections of name-value pairs having a hidden link to a prototype object. Every function is created with a prototype property. Its value is an object with a constructor property whose value is a function. Objects that are created with object literals, they get linked to an object.prototype. Objects created with function literals, it gets linked to a function.prototype, which itself gets linked to object.prototype. Functions can be stored in variables, objects, and arrays. Functions can be passed as arguments to functions, and functions can be returned from functions. Functions can have methods. This is a way to declare a new function. Basically, function name is required, the list of arguments is optional, and the body is optional. These are the function object properties. Arguments. Arguments is an array of the arguments that are passed to the function. The callee property returns the function object being executed. The caller property gets the function that invoked the current function. Constructor, it specifies the function that creates an object. Length gets the number of arguments defined for a function. Prototype returns a reference to the prototype for a class of objects. These are the function objects methods. Apply, it calls the function substituting the specified object for the this value of the function and the specified array for the arguments of the function. Bind method, for a given function, creates a bound function that has the same body as the original function. In the bound function, the this object resolves to the pass int object. The bound function has the specified initial parameters. The call method, it calls a method of an object substituting another object for the current object. ToString method returns a string representation of an object. Value of, it returns the primitive value of the specified object. So let's start with some examples that I have prepared. So examples 1, 2, and 3, it is the way to create a new function object. You have to use the function keyword. For example 1, let's see the output from example 1 returns 5. Example 2, since functions are objects, you can assign it to the variable add, and then you can use it that way. Example number 3 uses the new keyword and function. You specify the parameters and the body at the end. Let's see the output from example number 2. It's 5 as well, and the output from example number 3, it's 5 as well. So let's go to example number 4. Example number 4 is about argument, which is basically an array of arguments that were passed to the function. So if you have this sum function, actually you can use arguments.length to know how many arguments were passed, and then you're basically retrieving the value of each one and summing over all the arguments that were actually passed. So let's see the output. It is 108. Let's go to example number 5. In example number 5, we defined the recursive function called it's actually an anonymous function, which is being assigned to the variable factorial. Callee property is useful for those anonymous functions that need to call itself, but for which a name does not actually exist. So let's see the output from factorial 4. It is 24. Let's go to example number 6. This is about the color property. So for example, if you want to the function is called call level. If you want to call level from top level, let's reload the scripts. It's gonna be, it comes to line 34, it calls call level, it goes to function call level. If the color property it is null, it would print call by top level, which is the case. So now we call it from example number 6. So it's a function calling call level. So if we execute example number 6, called by another function. So the color property is not null this time around. So the constructor properties, if you want to find out which is the constructor, so we have a function called myObject, modifying the this object with the number property equal to 1. So let's see the example number 7 in action. Number 7. So first time we define a new string and assign it to x. If x.constructor is equal to string, object is a string. Variable y, you assign the object myObject. So you check on the constructor if it is equal to myObject, then it prints that, and we can see that's the output. So we go to example number 8. Example number 8 is about the length property. We define a function called myFunc with parameters a and b, and we print out myfunc.length and arguments.length. myfunc.length is how many parameters were actually defined with the function, and arguments.length is the actual parameters that were passed. So if we call myfunc with 1 and 2, it will print 2 and 2. myfunc 1, 2 and 3, 2 and 3, and myfunc with only 1 is 2 and 1. So that's the output. Example number 9 is about the prototype property. So in this example we can actually extend the prototype. Array.prototype already exists. We are augmenting the type with a property called .max, and to that we are assigning the function called arrayMax. So if we declare a new array with these values and we assign it to the variable myArray, it will call myArray.max. It will compute the maximum value from these numbers. So if we see example number 9 in action, it will return 25, which is the maximum number from the array. So example number 10 is about the apply method. It invokes a function as a method of a specified object, passing a specified array of arguments. So we define a function called callMe and we call it with 1 and 2, and we want to see the output from callMe.apply with 3 and the array 4 and 5. So let's see the output from example number 10. We see that this on the first call, that this object is the object window, a is 1 and b is 2. callMe.apply with 3 and the array 4 and 5, we see that this object is modified to 3, a is 4 and b is 5. The bind method. The bind method returns a new function that invokes this one as a method of the specified object with the optionally specified arguments. So for example, if we create a function and we assign it to the variable check range, this is to check a specific range that you want to check. So for example, the range minimum is 10, maximum is 20. So if we do check range.bind on that range, it will use this object to actually bind to that value. And then if you do and you call this function bound check range with 12, it would actually say true. So actually the function bind the check range function, it will assign it to the variable bound check range, and then you call bound check range with 12. This is example number 12. This is about the call method. This is very similar to the apply method. Call invokes a function as a method of a specified object with the optional specified argument. So it's basically the same thing. So example number 12. You see that this object on the first call is object window. A is 1, B is 2. On the second call, this object is 3, A is 4, and B is 5. So let's go to example number 13. This is the toString method. The toString method returns a string representation of the function. So for example, we want to build a table, an array of values from 0 to 15. You want to see the toString value of that number. So it's gonna go x.toString with base 16, x.toString with base 10. It checks the range, and x.toString with base 2. So let's see the output from example number 13. So it goes from 0 to 15. For each base, it creates the string representation of that number for binary, decimal, and hexadecimal, and then creates radix table. This is example number 14. This is the value of. So for example, you have an empty function, and then you create you call f.value of. It will return the function itself. So that's about it for function objects. Thank you very much. Hi and welcome. This is variable length argument list. Let's start with something simple. We're going to be talking about the arguments object. Arguments refers to the arguments object for a function invocation. The arguments object is an array-like object that allows the argument values passed to be retrieved by number rather than by name. Arguments.length property specifies the number of parameters passed to a function. Missing arguments are undefined, and extra arguments are ignored. So let's say that you define a function x that takes parameter x only. So and then you call it with two parameters, 1 and 2. So you can access the first argument as x or argument 0. And you can access the second one as arguments 1. So let's go through some basic examples. So on the left is the JavaScript. On the right we have the HTML. Each button is gonna call on a different example. So for example number 1, I define two functions. One called is foo, the other one is called helper. Helper is just gonna print the arguments for the function. Function foo is going to, you actually wanna pass the parameters pass to helper just to print the values, and you can also provide specify default values for the arguments. So we're gonna call foo 2 times. So let's see the output for example number 1. On the first call, we set name to Ken, address to main street, and email to user@LTP. So we see that we have a 4th argument. It is age, and it is set to null as the default value. On the second call for foo, we pass name Mary, email mary@user.com, and age 27. This time we didn't pass a value for address. So on the second call we define the email, the name, but we don't define address, and it is set as null. As you can see, you can refer to the list of parameters passed by name: args.email, args.name, args.address, and args.age. So let's see now example number 2. For example number 2, I define two functions. One is called load, the other one is called extend. So what this function is doing, you define like the default values for the expected parameters: name, address, and phone. And the extend function actually merges the expected parameters with any other parameters that you passed. So on this function extend is gonna check on the arguments dot length, and it's gonna check if it has own property. So you refer to the argument 0. So argument 0 is it actually refers to the whole parameters being passed. So for example, on the first one, argument 0, it would go through 3 different parameters: name, address, and age. So it's gonna check on if it has a property. If it has that property, it's gonna set that, and it's gonna modify the arguments object. So on the first one, let's see what it does. Example number 2. So for this first one, now we set the result of extend to context, and we just print context. So on the first call, it's gonna say name is Ken, address is 123 main, age is 28, and phone, since you didn't provide you didn't pass the parameter for phone, is gonna set it to default value of this. On the second call, you just provide an email. It's gonna merge with the expected parameters with the default values. It's gonna put for name, address, and phone. Since you just provided email, it will set that value for email. So now on the third call, you're passing only phone. So now it's gonna be setting, remember that expected are only 3: name, address, and phone. So name, address, and phone. You provided phone, it filled the value for name, and it filled the value for address. So you can actually refer to the parameters passed with the argument 0. You can also modify the value through this argument 0. So let's go to example number 3. The point of example number 3 is that you can actually do some checking on the parameters passed. So for example, you have the add function to add two numbers together. You can check the type of the parameter passed. So on the function add, you want to check the type of parameter A. It has to be a number. Parameter B, it also has to be a number. So on this one, we're defining a try and catch statement. So we're calling add 7 with the string 7. So it's gonna throw a type error, and it's gonna catch it, and you log it as e.name and then e.message. So this is very simple techniques to check the type of the parameters. You can also, how many parameters are actually passed. You can iterate through the arguments object and see the properties that it has. You can actually also define default values for the arguments. That's it for today. Thank you very much. Hi and welcome. This is event propagation in JavaScript. Let's go through some basic terminology. Event propagation. Most of the events that occur on the document elements, they bubble. There are basically three different phases for event propagation. Let's say we're talking about event capturing. In that case, the event is going to propagate going through window and then document, propagating through the body until it reaches the target. Event capturing provides an opportunity to pick at events before they are delivered to their target. A capturing event handler can be used for debugging, or it can be used along with the event cancellation technique to filter events so that the target handlers are never actually invoked. These are the phases and event listener. There are three phases for event propagation: phase 1 capturing, phase 2 target, phase 3 bubbling. The event model is standardized to be DOM level 2. There is this function called add event listener, which registers, is basically a listener for the events, and then this method registers the specified listener function as an event handler for events of the specified type. So there are some event object constants. So for example, when you are at capturing phase, that is DOM level 1. When you are at the target, that is DOM level 2. And when you are at the bubbling phase, it is DOM level 3. These are some event object properties. You can use bubbles, cancelable, current target, event phase target, timestamp, and type. All these you can use to read the specifics about events. So let's go through some basic example that I have prepared. Basically, I define an HTML file, a JavaScript file, and a CSS file. So on the right we have ep.html, on the left we have that file. We see there is very simple HTML. It is basically 3 divs, div 1, 2, and 3. The innermost is div 3, the outermost is div 1. So I define 3 divs, and then let's take a look at the CSS file. Basically the basic rules for displaying these divs, specifying the width, height, background color for all 3. And let's start with the JavaScript. Let's open the console. So here, what I want to do is I'm gonna be clicking on these divs and see how the clicking event it propagates through these divs, since they are contained within each other. These are elements in the DOM tree that actually they propagate through the whole DOM tree. So phase 1 is capturing phase, phase 2 is target, phase 3 is bubbling phase. So I'm gonna start by registering an event handler, and I'm gonna be printing event.bubbles, event.target, current target, event phase, and type. It's gonna be showing here in the console. I register the event handler, and then I get the div list, get elements by tag name div, and then I'm gonna start by doing the bubbling phase. So the bubbling phase is going to go through third, second, first, body, and then document, and then window. So let me comment this out. So let's save it. Okay, so I'm gonna be clicking on third. So this is what is showing. So bubbles, this is a bubbling through. The target is the third div. The current target is the third div. Event phase is 2. Event type click. So that was the first sequence of in the event propagation. So then it goes to from the third div, it goes to the second div, and then it goes to the first div. So event phase 2 it means it is at the target. Event phase 3 means it is doing the bubble. This is the bubbling phase. Once it goes to the second div, it goes to the first div, and then it goes to body. So what happens if I click on div 1? If I click on div 1, it goes first div and then just goes to body. So it goes in that way, reversed, not reversed, but it just goes first div and then body. So how about second div? Second div, first div, body. So let's say now that I want to do the capturing. So this is third parameter in the add event listener. When you register this click event, you are using the event handler when the click happens, and then false, it means it's going to be doing bubbling. If you set the third parameter to true, it's going to be doing the capturing. So let's see what it does now. So this is now capturing. It's going to go from window, document, body, first, second, and third. So if I click on the first div, so it goes target is first div, current target body, from the body it goes to first div. That's it. Capturing. So now if I want to capture div 3, so it goes from body, first div, second div, and third div. And then you can see the event phase is 1, 1, 1, and then when it reaches the target in the capturing, it says 2. When it reaches 2, it means it is at the target. When it is at 1, it means it is in the capturing phase. So it registers the event type click, and then it means it also I'm printing the event on target where it wants to go. So it wants to go to third div. The current target is second div. So this is pretty much it for event propagations. It's pretty simple. It's just capturing phase, a target or bubbling phase, and this is the CSS that I defined, and this is the HTML, and this is the JavaScript. Just register having an event handler, and then just register the event, and then saying change the third parameter to either true or false. It changes to false, it is bubbling; true, it is capturing. So that is it for event propagation. Thank you very much. Hi and welcome. This is objects in JavaScript. So let's start with something very simple. The objects. What is an object? An object is an unordered collection of properties, each of which has a name and a value. Anything that is not a number, string, boolean, null, and undefined is an object. Objects inherit the properties of another object called its prototype. Objects are dynamic. Properties can be added and deleted. Objects are mutable and manipulated by reference. A property has a name and a value. The property name can be any unique string in the object, including the empty string. Property value can be any value. These are the property attributes. There is writable, specifies whether the value of the property can be set. Enumerable specifies whether the property name is returned by a for loop. Configurable specifies whether the property can be deleted and whether its attribute can be altered. These are the object attributes, and the prototype is a reference to another object from which properties are inherited. Class is a string that categorizes the type of an object. Extensible is a flag that specifies whether new properties may be added to the object. These are the categories of JavaScript objects. Native object is, for example, arrays, functions, dates, and regular expressions. A host object is regularly HTML element objects, for example, HTML and the body. A user-defined object is an object created by the execution of JavaScript code. An owned property is a property defined directly on an object. An inherited property is a property defined by an object's prototype object. Let's start with the basic example. So example number 1 is how to create an object. Basically, empty curly braces, enclose the properties. On the left is the name of the property, on the right is the value of the property. So if we define an object, an employee, and a flight, the flight has 3 properties: airline, departure, and arrival. Employee has 2 properties: first name and last name. An object, it does not have any properties. So let's look at example number 2, which uses the new keyword an object.create. So for example, if we call on the constructor of the object, new object, it will create the empty object. New array will create the empty array. New date, it will return the current time, and a regular expression for pattern matching. So we can also use object.create and pass the prototype for the object that you want to create. It will inherit X and Y, and will assign it to object 1. Object 2 will actually inherit nothing because you are using null. Object 3, you will call on object.prototype. It is the same as the empty object. So let's look at point. What does a point have? A point have basically a coordinate in 2D space, an X coordinate and a Y coordinate. So let's define a point with coordinates 1 and 2. So let's see the output of example number 2. So let's define also a circle. A circle has a point, basically the center of the circle. It has a radius. Let's define the radius to be 3, and an area. Let's calculate the area with the property, which is actually defined with a function, which for which you pass the radius. So then we assign the circle point. We change the center of the circle to be 2, 2, x2, y2. So on the first log output, actually, we're printing point. Point is actually an object that has x1 and y2. For the circle we see that it has a point, x2, y2, and the area is calculated and returned, and output as 12.56. So now let's look at the sphere. What does a sphere have? A sphere has a circle and volume. So for example, it is containing another object, and we have a property called volume, which returns the volume of the sphere. So we output a sphere.circle. So this is very interesting. If we expand this, we can see that it has an area property. It has an object called P, and then we see all these properties and methods that are inherited from the object.prototype. It also has a property called sphere.volume. So you can see that it has the define getter, define setter, lookup getter, lookup setter. These are part of the legacy API for looking for properties. It inherits also the constructor property, has own property, is prototype of, property is enumerable, and to local is string, to string, and value of. So this is in very general terms how you define your own objects. Thank you very much. Hi and welcome. Let's look at some examples about object properties. Let's start with example number 3. On example number 3, we define an object called flight with several different properties: airline, number, status, departure, and arrival. So let's start with something called reflection. So on the properties that get, some of them are own properties, some other are inherited properties. The inherited properties come from the object's prototype. So if you create an object, for example, this one called flight is going to inherit some properties from object.prototype, as well as it will have its own properties, which are defined in the object: airline, number, status, departure, and arrival. So let's look at the output from example number 3. So as we see, we do type of flight.airline, flight.number, and flight.constructor. Flight.constructor is part of the inherited property, and it's actually a function. So we can also check if it has a certain property. For example, if you wanna check if it has own property called number,
and that is true. We want to check if it has own property constructor. Even though it has that property, is not an own property, it's an inherited property, so it will output false. If you want to check if a property is enumerable, you check on number and toString. toString is an inherited property, it will say false. Number, it is an own property, it will say true. So for example, if you want to check if object.prototype is a prototype of flight, that is true. That is where the inherited properties come from. So if you want to enumerate the own properties, this is how you do it. If you want to skip the inherited properties, let's say that you say in a for loop for var prop in flight, for all the properties in flight, check the type of the property that is not equal to function. If it's not equal to function, just output the property. It will output airline, number, status, departure, and arrival. So if you want to read and write the properties, so for example, if you want to change the status of the flight from originally it was the value is on time, we want to modify that to be delayed. So you can go directly using flight.status and then you assign the value delayed. And then if you output, for example, you can also read it using the brackets, and then inside you specify the property surrounded by quotes, flight status. You can also get the value like that, and you can see the output. Originally it was status was on time, and then you change it to delayed, and then we output it. So for example, let's say that you by mistake you want to access a non-existent property. So for example, if you call on fly.airline.airport, that is an undefined value. That's property is not existent. So now if you still want to read from an undefined property, for example, fly.airline.airport.name, .airport returns undefined. So now if you still want to read from it, you will get a type error. This is a way how to delete a property. So for example, there is flight.status. If you want to delete it, you just use the delete keyword, delete flight.status. And then if you just to check, if you want to check if it has that own property called status, it will return false. So adding a property, objects are dynamic. You can add and delete properties. So if you want to add this property called within departure.terminal, let's say you assign it to the value A, flight.arrival.terminal, you're adding this property to arrival with the value 24. So then just for testing the properties, you can use for example, flight has own property called departure. That is true. Flight.arrival has own property terminal. That is true. So you can access the properties also by level, by referring it with the dot, flight.arrival or flight.has own property. So in general terms, this is how you access the properties, change the properties, or you check if a property is existent, or if you just want to enumerate the properties of an object. There is a clear distinction between own properties and inherited properties. Inherited properties come basically from the prototype, and the object can have properties, many different properties inside of it, as it is here on the flight object. Thank you very much. This is it about object properties. Hi and welcome. Let's go through a simple example about defining a get function and a set function for an object. So let's start with example number 4. Example number 4, we define an object called circle. On the circle we have
three properties: property X and Y, which define the center of the circle, and R, which defines the radius of the circle. So to define, for example, a function called area, we use get and then the name area, and then just you can define with the return statement math.py times this dot r times this dot r, that will return the area of the circle. Let's define also a set function to change the value of the radius. These you have to define refer to the radius as this dot r, and then you can change it like that. So let's output example number 4. So the first value refers, we are printing circle.area, and then we change the value of the radius in this way, circle.radius. As you can see, this is actually a property. So that's how you can change the value of the radius. It is defined with the parentheses, and then you actually change the value with the assignment operator, and then you just actually print circle.area after you change the radius, and then we can see the change to 12.56. So this is very simple example about get and set functions for an object. Thank you very much. Hi and welcome. This example is example number 5 is about the object methods and the JSON object. So the object methods, for example, when you create an object and inherits from the object of prototype, it inherits these methods. So for example, the first one, if I create the object with one property, one value x1, so if you use the to string function, it will return a string representation of that object. For example, on the second one, bar c equal to the object with the property y, and then to local e string, it will return a localized string representation. And then we also have value of, which will convert to something other than a string. So let's just print the value of the output of example number 5. So first we are printing type of S, type of C, and type of P. You can see the first two are strings, the third one is an object. So let's declare a JSON object. A JSON object, as you can see, you declare some properties with a name and a value. So how can we get these values? So basically you use the dot. For example, JSON object.name or JSON object.age. It will return, for example, John Johnson and age 33, as you can see on the output. So let's define another JSON object. In this case, it's called text. In this text, you have many strings, many lines. That defines the employees. So for example, you have first name and last name, first name and last name, and first name and last name. You have 3 employees. So what you want to do first is you want to parse this. So you parse and you pass in text, and then you store it in object, and then in object you can access these properties with an array index. So if you say object dot employees one dot first name, it will return you the first name of the employee with index 1, which would be Anna, and then again for the last name it will return Smith. So now let's define, for example, this object that has properties within itself. So property y has another object that has property C
with the values false, null, and dash. So for example, if you call on JSON.stringify, it will return like a string version of this object. Actually, the properties get like strings, string X, string Y, and string C. So now if you parse it, you can refer to the properties. For example, if you say P and then you call it on X, you get the value 1. And then for example, this one that is a property inside another one. So property Y, and then you want to retrieve property C within Y. So you can do this with indexes. So 0, 1, and 2, it will return you false, null, and dash. So this is very simple example about how you create a JSON object and how you can retrieve the values stored within the JSON object. How can you parse the information in the object? You can also use a stringify to get the parameters using strings. How can you access also the elements using index array? So that is it for this example. Thank you very much. Hi and welcome. This is example number 6. This example deals with properties and the object properties. So example number 6. So let's call on object.getOnProperty descriptor. So this will return all the property attributes. So for example, let's create an object and pass that to the property descriptor. This object has one property called X with value 1. And let's return the property descriptor for X. So we see on the output that this is an object with value, the property has value 1, writable it is true, enumerable is true, and configurable it is true. So from this we can deduct that the property it is a known property which you can modify, you can list from the object, and you can also configure. So let's talk about object attributes and the prototype. So for example, let's create an object called P, an object called O with object.create, but we pass P in. So now we ask, P is prototype of O, that is true, and it will inherit, O will inherit the property X. So now we ask the question again with this object.prototype.is prototype of P, that is true. So in a sense, all objects that are created with the curly braces object.create or with the new keyword, they are all mapped to the object.prototype. So they will inherit all the properties from this prototype, and they will also extend to have their own properties defined in the object itself. So for example, if you want to check on an object's class, so for example, if we output, we create this object with one property called X and value 1, and then we call on toString, it will return something in the form of object and class. We see that the output is saying object. Actually, the class, it is an object. So for example, if we write this class of an object, we just want to return the second value from this return. So if it is null, we return null. If it is undefined, we return undefined. But if that's not the case, we just want to print the second value, and we can see that we can get that value with the class of the empty object. It will return object. You can do the same for any other object. So there is also the extensible flag. So for example, if you call object.isExtensible using the array.prototype,
It is true. What this means is that the array.prototype, you can extend it. You can add methods to objects created from the array, from the array object. So the array object will inherit everything from the array.prototype, and then you can add those methods, and those methods will get added to the prototype. So that way you can extend that the array object. So this is a very simple example about property attributes and object attributes. Thank you very much. Hi and welcome. This is JavaScript arrays. Let's start with something very simple. Arrays are ordered collection of values. Each array element has an index, and it may contain elements of any type. Arrays, they convert indexes into strings that are used to make properties. Arrays are zero-based. They are dynamic. They can range from 0 to a maximum of 2 to the 32 minus 2. They can be sparse elements. They don't need to be next to each other. Each array has a length property. For non-sparse, it means that the length is the number of elements in the array. For sparse arrays, it means that the length is always larger than the index of all the elements. And they inherit properties from array.prototype. Let's start with a simple example. So example number 1 is different ways to create new arrays. Let's create the empty array called A with the brackets. We can also create a sparse array. You can see it has non-existing elements. It has elements of different types. We create another empty array with the new keyword. On the next one, array. The array called array is created specifying the length. When you only have a single argument, that represents the length. When you have several different values given to the constructor, it will create the array with those values. So for example, if you want to access a non-existing element, for example in the sparse, you try to access the sixth element. It's actually the 7th element with the 6th index. That will return undefined. For the next one, if you try to read from an invalid index, -1 will get converted into a string, and will be treated as an object property, not as an array index, which is non-existent, so it will also return undefined. So now we check the length of the sparse array. It is 8. The length of the empty array and the A array, they are both 0. The array.length is 5, and the array2.length is 5. Let's check the output. We can check 800 and 55. Well, those are the different ways to create the arrays. The very important point to take is that the index gets converted into a string, which will be used to access the elements. Thank you very much. Hi, this is example number 2. This example is about how to read and write from arrays, how to access sparse arrays, how to check on the length, how to add and delete elements from the array. So let's start. Let's create an array called array with 5 elements, index 0 to 4. So now we want to add array 5. So now it's going to append that to the array, and the length is going to change to 6. So let's output that. We can see that from the example is the length is 6. It has 6 elements with indexes going from 0 to 5. So now for that array, let's insert at index number 10 the value 11. So actually it's going to set the value 11 at that index, but it's going to create a sparse array because it's going to have elements that are not there. So actually the length gets changed to 11 with only 7 elements in the array. So as you can see, the output is 11 for the length. So this is the concept of sparse arrays. The elements, they don't need to be next to each other, but if you try to access non-existing elements, you will get undefined. So if we create a new array called A with length 5, it will create, the length is set to 5, but it actually doesn't have any elements. You can also create an array A1 like this using commas. Actually, the last comma is a trailing comma, and it's not going to create another element for that. So the length is 2 with no elements. Array A2. Let's say that you insert for the very first one undefined, and then a comma, again the last comma is going to be trailing, so it doesn't create another element for that. So the length is set to 2, and it has one undefined element. It's very different having a non-existing element to an undefined element. So now we check on the length, we can see that A1.length is actually 2, A2.length is 2. So the length is the same, but one has no elements, the other one has one element. So if we check on the index in A1, it's 0 in A1, so it's asking if it has an element there. That is false. In A2, we check if the first one has an element, it will return true. A2 has element undefined at 0. So now we create an array called B with 5 elements. So you can also change the length of the array, which will change the array itself. So it will delete 4 and 5. You can delete all the elements by setting length to 0. And you can also actually change the length to 5. The length will be 5, and it has no elements. So this is another way to add elements to the array. Let's create the empty array called C, and let's push 1, 2, and 3. Basically, it creates the array with the elements 1, 2, and 3. So now we delete the index 1, the element at index 1. So it will create an sparse array, and you can see how it has a placeholder there on the output. So we ask the question, is 1 in C, does it has an element in index 1? It will return false. And then we check on the length, C.length, we can see the length is 3. So that's it. This is the way to add elements to arrays, delete elements from the array, check on the length, and when you have non-existing elements, and the way to access elements by using the numeric index or the string index. That's it for today. Thank you very much. Hi and welcome. This is example number 3. This example is about how to read the elements from the array and how to create multi-dimensional arrays. So for example, let's start with an array called A with 5 elements. Let's create an array called array with numeric elements and also nulls, undefined, and non-existing elements. This is a sparse array. Let's create the index variable I to loop through the arrays. So we can print the elements in a non-sparse array. For example, if you say for I in A, so if you access and print A of I, so let's see the output. So for the very first code lines, we see that the print is 1 to 5. So there's another way that you can use a for loop. Using the index variable and then checking on the array.length and then iterating through the array elements. Let's say that you want to skip the nulls, undefined, and non-existent, and this is the condition that you specify. Just continue, and then the same way you just specify array and then you pass the index. It will print only the numeric elements or the elements that are not nulls, undefined, and non-existent. So this is a way to create a multi-dimensional array. Let's say that you want to create a multiplication table, every element in the table is the product of the row value times the column value. So we create a table, an empty array with 5 elements, 5 rows, and then for every row we want to insert a column. So we get a 5 by 5 table. So now we want to insert values into the table. So we need 2 for loops to insert the values. So we loop through the table, and then for every row and for every column, we compute those values and store it in row and col. So the way to access the values, you use index, row index 2, column index 3, and then that will output the product. So this is the way to create multi-dimensional arrays. This is the way to loop through the arrays. This is the way to also to skip undesired elements, nulls, undefined, and non-existent. That's it for this example. Thank you very much. Hi and welcome. This is example number 4. Example number 4 deals with the different array methods available. Let's start with the join function, and let's create an array called A with 5 elements, and then we call a.join. Let's print the output from example number 4. A.join will convert the elements to string, concatenate, and then return the string. We can see that it returns this string 1, 2, 3, 4, and 5. We have also the function called reverse. Reverses the elements of the array and returns the reverse array. It modifies the array. We can see the output is 5, 4, 3, 2, and 1. We also have the sort function. The sort, it sorts in alphabetical order, case sensitive. It modifies the array. If you want to sort in another way that is not alphabetically, you have to pass in a comparison function. It will go through the array basically, and you specify 2 arguments. The first one, it is a placeholder for the previous value. The second argument is a placeholder for the current element being analyzed. It will compare these 2 elements at a time, and then it will compare them, and if necessary, it will do this, the swapping. So for example, if we have an array called fruits with the values apple, orange, and banana, if we call fruits.sort, it will return banana, apple, and orange. Probably that's not what you want. You want case insensitive. So if you specify sort and you pass the function with arguments s and t, this will go through every element in the array. S will be in the first call, it will be like the previous value. T will be the current value. So it will compare apple and orange. It will convert them to lowercase, compare them like that. If necessary, it will sort the elements, and then it will repeat this process until the array is sorted, and it will return the array with the values apple, banana, and orange. So we also have the concatenation function. So it will return a new array with concatenated elements. It returns the new concatenated array. So we create the array called x with values 1, 2, and 3, and then we concatenate with elements 4, 5, and a new array 6 and 7. It will return the new array with these elements 1, 2, 3, 4, and 5, and the array with elements 6 and 7. We also have the slice function, which is like a function to return a subarray. It does not modify the array. You pass 2 arguments, x and y. X is the starting index, inclusive. Y is the end index, exclusive. It means it's not included on the subarray. This is the way to think about the indexes. So for example, you have 5 elements, 0 through 4, or you can also access the elements in using a negative value. So -5 to -1. So we create the array called C with these elements 1 to 5, and then we call a slice on 0 and 3. It will return 1, 2, and 3. It will go to this index and this index 0 and index 3, and then return these values. And then, for example, for the next one, a slice of 3, it will go to this index 3, that's the value 4, and then it will return the rest of the array 4 and 5. And then in the same way, you can say 1 comma -1, it will return the elements 2, 3, and 4. A slice -3 and -2, it will return 3. You also have the splice function. The splice function is for deleting one or more elements. Splice of x and y. X is the deleting index, y is the number of elements to delete. It modifies the array and then moves elements over to the left. So if we start with array f with the elements 1 through 8, if you call on a splice of 4, that's saying go to that index and then delete all the elements to the right of that that index. So it will return 5, 6, 7, and 8, and now f is 1, 2, 3, and 4. A splice of 1 and 2, it will return 2 and 3, and f is 1 and 4. It's basically cutting those elements from the array. So now if you call again a splice on 1 and 1, it will return 4, and f is now 1. You also have the push and pop. Push is used to append at the end of the array. Pop deletes at the end of the array. It modifies the array in place. So let's start with an array called stack. If you push the elements 1 and 2, it will append these values to the array. Pop, it will delete from the end, so you will get 1. Push 3, now you will have the array with 1 and 3. Pop, you will delete the 3. Push 4 and 5, you will insert the array with elements 4 and 5. Then you say pop, it will delete that array. If you say pop again, then you will have 1 and then the empty array. Shift and unshift. Shift is used to delete at the beginning. Shifts elements to the left. Unshift is to insert at the beginning. It shifts element to the right as well. Shifts elements to the left, that's for shift. So with the empty array called h, if we unshift 1 and unshift 2, it will insert at the beginning, so we get 2 and 1. Shift, you will delete from the beginning, it will remove the 2, you get 1. Unshift 3, 4, and 5, it will insert these 3, 4, the array with elements 4 and 5, and then the last element with value 1. And then if you do unshift 3 times, you will delete the 3, you will delete the array, you will delete the element 1, the value 1, and then you will get the empty array. You also have the toString. ToString returns a string with a array element. So for example, you have an array with values 1, 2, and 3. Dot toString, it will return the string 1, 2, and 3, as we can see here. So for example, let's say that we have a string defined like this, an element and an array with elements 2 and the letter C, and then we call toString, it will return 1, 2, and C. So it will grab all the elements and basically make a string. So you also have index of and last index of. Index returns the index for the first occurrence of an element, and last index of returns the index for the last occurrence of an element. So let's say that we have an array like this. So if you want to know the index of the value 5 in the array, it will return 7. You want to know the last index of 3, you see that you have several 3s there, so it will return the last 3, and the index for the last 3 is 9. 7 and 9. So now we also have these methods for which you have to provide a function. These methods are called for each, map, filter, every, sum, reduce, and reduce right. The first argument is a function, and invoke that function once for each element of the array. The function itself takes 3 arguments. The function that you are passing, it takes 3 arguments. The first is the value of each element in the array. The second is the value of the this keyword, and the third is the return value. So let's go through the for each. So for example, in the array 1 through 5, you define variable sum. You want to compute the sum of all the elements. So this is saying that for each value in the array, it will pass each value of the array to the function, and then it will start adding and computing the sum, and then you can see that it returns 15. So you can also there's a function called map. You can pass this function to map values in the string in the array. For example, for the array 1, 2, 3, 4, and 5, you want to map those values to a specific function. So for example, for the squares, right? So for each value in the array, you will compute the square like this. You will return 1, 4, 9, 16, and 25. There's another function called filter. So if you want to specify a specific filtering option, you call, let's say that you want to look in the array for values smaller than 3, array.filter, you pass the function, x will be every element in the array. So now you will return the values that for x that are less than 3. So it will return only 1 and 2. There is a function called every and sum. It returns true or false. This will also have a comparison. So for example, if you want to define a comparison function to return the elements x less than 10, so all the elements that are less than 10, does it have and those? That's true. I mean all the elements are less than 10. You can look for some comparisons to be true. For example, every other element, does it have some even? It will return true. So we see that returns true and true for both functions. You also have the reduce function. So this is a little bit interesting. So this function is used to combine elements that produce a single value. So for example, reduce takes previous value, current value, the index, and the array. So for example, you define an array with the values 0 through 5, and then you call reduce, and then you pass the function x and y. So x and y, x will be previous value, y will be current value, and then index and array. So for example, on this one it will return 15 because there's also an initial value which is optional, which you're specifying to be 0. So it will go and add every element in the array and then return it plus the initial value which you specify to be 0. It will return 15. So this is very similar, called reduce right. This is used when you want to make computations from right to left precedence. So if we go again through the function, the same function, you don't specify an initial value. So on the previous value will be 4, current value will be 3. So it will process pairs of elements in the array. So the index will get changed, it will get reduced from the right to the left, and then at the end it will return 10 because you did not specify an initial value, and that's the sum of the values of the sum of the elements of the array. If you call reduce right with an initial value of 10, It will do the same thing, but at the end, I mean, it will start with the previous value of 10, and then the current value will be the last element in the array, and then they will keep adding the elements, and then it will return 20. Well, that is it about the array methods. These are all methods which you have to provide a function, and these are methods in which are ready available, and you can use them. You can specify arguments to change the functionality. And that's it for today. Thank you very much. Hi and welcome. This is JavaScript classes. Let's just start with something very simple. Classes. Object-oriented programming is a programming paradigm that uses abstraction to create models based on the real world. It uses techniques such as modularity, polymorphism, and encapsulation. It is the design of software using a collection of cooperating objects, as opposed to a program that is seen as a collection of functions. Each object is capable of receiving messages, processing data, and sending messages to other objects. Object-oriented programming is intended to promote greater flexibility and maintainability in programming, and it is widely popular. The emphasis on modularity lends itself to be simpler, more direct analysis, coding, and understanding of complex algorithms. What is a class? It defines the characteristics of an object. An object is an instance of a class. A property is an object characteristic, such as a color. A method is an object capability, such as walk. Constructor is a method called at the moment instantiation. Inheritance is a class that can inherit characteristics from another class. Encapsulation is a class defines only the characteristics of an object. A method defines only how the method executes. Abstraction is the conjunction of complex inheritance. Methods and properties of an object must be able to simulate a reality model. Polymorphism, it means that different classes might define the same method or property. Let's just start with a simple example. Example number 1 deals with classes. So let's start by creating a new class called person. We use the keyword function. The constructor has a parameter called gender, and we assign it to the property called this.gender. We use this to refer to the current object. Every time a person gets instantiated, it will log that message, and then we can extend the prototype object. We can list, for example, say hello function, and then we define it, return hello, and say gender. We define the function returning this.gender. So we start using the classes. We define two instances, person1 and person2, and gender teller, which points to say gender. So for example, on the output, we see that we create person1, person2. One is male, the other one is female. We get two instances, and then we log person1 is a person1.gender. Person1 is a male. And then we call person1.say hello and person1.say gender. It logs hello and male. And then we check, for example, is gender teller, is it pointing to the same as person1.say gender? That is true. Gender teller, is it the same as person.prototype.say gender? That is true. And then we call from gender teller.call person1 logs male. So the point of this example is how to define classes, how you can extend the prototype, And how can you can also for example point a function to another object in which you can later call later. For example, in this genderTeller.call person1, so there's no like object specific methods. You can actually point a function to a brand new object, and the object then can call that function through the original instance. So let's go to example number 2, deals with inheritance. We define a person class. We extend the prototype with the methods called walk and say hello. So we define the student class. Every time we create an instance of student, it will call the parent constructor. In this case, it will call on the person's constructor, and pass the this object. We can also see how we can inherit from person, student.prototype, and then we say new person. So we will inherit everything from person, and then extend it and assign it to the student object. And the constructor originally points to person. We change that to now point to student. We replace the say hello method. So for example, in this case, the person already had a method called say hello. We want to change that and say hi, I'm a student, instead of just saying hello. And then this is what it refers as encapsulation. For example, a student inherited this method called say hello. Student inherits this method and changes it, but it also inherits walk. It doesn't really need to know how walk is implemented. Only if he wants to change it, you need to define it. Otherwise, you can just go ahead and use it. You define also a method called say goodbye, like that. And then we check on inheritance. Is the student one an instance of person? That is true. Is the student one an instance of a student? That is true. So you can also create inheritance by using this technique, student.prototype, and then you assign it from whatever is returned from object.create, and then you pass person.prototype. Example number 3 deals with abstraction. Abstraction, what it really means is that is basically a specialization which is achieved by inheritance and composition by letting instances of classes be the values of attributes of other objects. Function class in this case inherits from the object class. That is a specialization. And the function.prototype property is an instance of object. That is called composition. So in this case, for example, you create a variable called foo, and then you define it as a function. So foo is a function. Foo is an instance of function. That is true. And then you check on foo.prototype is an object. Foo.prototype instance of object. That is true as well. So you can see how it derives from the object.prototype and inherits all the methods, and then it creates a brand new object. So that is it for classes. Thank you. Hi and welcome. This is modules and namespaces. Let's start with something very simple. What are modules? Modules allow large programs to be assembled together using code from disparate sources, and for all that code to run correctly, modules should minimize the number of global symbols they define. Module has a public API that they export. These are the function, classes, and properties and methods that are intended to be used by other programmers and can return a namespace object. Module implementation require additional functions of methods that are not intended for use outside of the module. Variables and functions defined within another function are local to that function and not visible outside of it. We can use the scope of a function as a private namespace for our module. Let's start with a simple example. So let's say example number 4 deals with modules. For example, if you want to define a module, this is the way to do it. You define it as a function, and then you define the scope, and then you call it. You have to invoke the function. Any variables used by the module are local to this function instead of cluttering up the global namespace. What is the intention of this is to avoid name collisions. For example, when you are using your functions, you want to avoid name collision with something that might be already existing there. So what you do, you encapsulate your methods and variables in a namespace object. So that way you can call your functions using the public API without any problem of actually overriding, but having a name collision with something that is already existing. This is another way to define a module. You see, you can enclose it with parentheses. This is my module function rewritten as an unnamed expression. Module code goes here, and then you have to call it using the open and close parentheses. You can create a single global variable to hold all the collection related modules. For example, in this way, you create collections and then you define it like this. You check if it is not defined, then define it as an empty object, and then you assign it to a namespace object. So you create the module like this. For example, you have to list the private variables, private methods, and then you include a return statement with the export API, which is being returned by a namespace object. So in this way you can use these functions from your namespace, or which is defined inside the module. This is yet another way to define a module. You see that there is no return statement. You use the this keyword, and even there is a third way to do it, which is actually referring the whole module and then the public method included. There is no return statement here as well. So these are 3 different ways to define a module, and how you can actually also define a namespace. As mentioned before, you take advantage of the function scope. Everything will be local inside the module, and only whatever you are returning is what is going to be available as a public API. Thank you very much. Hi, this is example number 5. Example number 5 deals with namespaces and modules. This is a very simple example on how to define a namespace and also constructing a module. So you construct a module using the function and then enclosing it with the open and close parentheses and then calling it right after. So you create the namespace called jspy. You create a private variable called _count. You set it to 0. Private methods, increment count, recent count, and get count. And you see the function definitions there. And then this is the public API which you are returning. You're returning as increment, reset, and get. and these they will call the private methods. So for example, if you create you call jspy.increment and then get and then reset and then get, we see the output. You see that increment incremented the count variable to 1, and then you basically just output the count value, and then you reset it, which is going to reset it to 0, and then just print that value, and then it shows 0. So this is very important concept, in which inside the module you declare the private variables, private methods, and this is the public API that you expose to other programmers, and this is how you can define the module, and then you return it in a namespace object called jspy. And this is how you can use the namespace object like this. Let's go to another example. Example number 6 deals again with namespaces and objects. So first, what you want to do is you want to create a root namespace and making sure that we're not overriding it. So you call you create a root called my application like this. You declare it and define it like this, and then you want to create a general purpose namespace method, and this will allow you to create namespaces a bit easier. So you define the function create namespace, and then you will split it on the dots. So for example, you want to create my application product products. So it will you just specify that name, and it will create that namespace. You want to exclude the root namespaces, so so you start going through the parts of the namespace. You will slice it. You will create a nested namespace if necessary. It will loop through it. So for example, here you want to create a namespace for products. Let's say that you want to create a namespace called my application.model.products. It will split this using the dots, and then they will create a nested namespace like this. So now you want to create actually define my application.model.products.product. This is a method, actually the namespace that you're defining as part of products. You define private variables, you define private methods, and then you expose the public API as get width and get height. You create also a namespace for the logic. Create namespace my application.logic.business. So you want to create a product. You create you call the namespace model.products, and then returning as model. You call them model.product. You specify 50 and 100 for width and height, and then you can use it like this with my application.logic.business, and then you call that method, and you see that it returns a product with this specification, width and height 50 and 100. So these are very straightforward ways to create namespaces and modules. This is a way to create a nested namespace. You can also define a specific namespace object like this. Thank you very much. Hi and welcome. This is JavaScript HTML DOM. Let's start with something very simple. What is DOM? DOM stands as Document Object Model. When a page is loaded, the browser creates a DOM of the page. HTML DOM is constructed as a tree of objects. The DOM is separated into three different parts. Core DOM is a standard model for all document types. XML DOM is a standard model for XML documents. And HTML DOM is a standard model for HTML documents. Let's start with some basic examples. Let's say that you define HTML like this with embedded JavaScript like this. So let's say that you want to find HTML elements by ID. You would call on get elements by ID, and then you pass the ID of the element that you want to retrieve. And then if you say, for example, in this case, x.innerHTML, you will print out the text value of that element. You can also do it by tag name. If you define a div with two p elements, you can get the element by ID or get elements by tag name. It will return basically like an array for that tag name. So if you want to access that, you would have to index. You can also do it by class name, by calling on get elements by class name. You also have object collections. So let's say that you define a form like this called form1 with two text fields called first name and last name, and then you define submit button. So just on the script, if you want to see what kind of values are there, so on docs x.length, you would say x.elements I dot value. So what it would retrieve these values called Donald for first name and Doug for last name. That's the way it is stored in the form. These are the HTML object collections accessible: document.anchors, document.forms, document.images, and document.links. You can also change the HTML output stream. You can use document.write, can be used to write directly to the output stream. But if you use it, it will overwrite the document after the page has loaded. But as an example, you can say document.write and then call on the date. It will print the current date and time. You can also change HTML content. If you define a p element and h1 element in the script, if you modify the dot inner HTML, it will change the text value of that element. You can retrieve the element, and then again the same way, just change the inner HTML. It will change the content of that element. You can also change the value of an attribute. So for example, let's say that in the HTML you have a reference to an image called smiley.gif. You can say get element by ID, the ID is image, and then on the attribute.source, if you change it, it will change the image from a smiley to landscape.jpg. You can also change the CSS. If you define a p element and then you call get element by ID dot style dot color font family or size, you can change the color, the size, and the font of the original element. You also have events. Events are generated by the browser when the user clicks the mouse, the web page has loaded, an image has been loaded, the mouse moves over an element, an input field is changed, or a user strokes a key. So for example, in this case, for the button, if you define an event handler for the on-click event, let's say that when the user clicks the button, it will call on this function called get element by ID, and then it will change this the color like this. You can also change the visibility. So every time the user clicks on the on the button, it will change the visibility of that element to be hidden or visible. In this case, you have two different buttons. One is called with the value hide text, the other one is show text, and in that case it will change the visibility to visible. You can change you can also change the content of a H1 element. For example, if you assign an on-click event, these are inner HTML, you can change directly the content. So instead of click on the when you click on the text, the value is click on the text. When you click on it, it will change to oops. So you can also call a function from the event handler. So let's say that you define an H1 element, and then for the event handler you call change text, and then you pass a this object. So when you click on the H1 element and it reads click on the text, when you click on it, it will change that that element to oops, and just the same as it did on the previous example. But on this one, you are using the event handler to call a function. You also have HTML event attributes. You can assign a non-click event to a button element, and then a function called display date will be executed when the button is clicked. So if you have the button on the on-click event called display date, and then you can change the inner HTML, and then you can assign the current date and time to that element. And then you have another element P with ID demo, in which it will be written. So if you say get element by ID demo dot inner HTML equal to date, so it will assign a date to that P element. So you can assign that function to a button, which will be executed when the button is clicked. So the button ID is my button. So on the script, if you assign the dot on click for the button, you will be calling on this function called display date. This display date is defined below, which will get the element by ID demo, and then just override the text value of that element on using dot inner HTML, and then just assign the date value. You can also have onload and onload events are triggered when the user enters or leaves the page. Onload can be used to check the browser type and version. So for example, on this example, we can check on the cookies. So when the body, when it is done with the onload event, it will call and check cookies, and then it will check if the cookies are enabled. If they are, it will output cookies are enabled, or otherwise it would say cookies are not enabled. So you also have on mouse over, on mouse out. So if you have a div like this, in which you define two events, on mouse over and on mouse out, if you have a div defined with this style with a background color, which is basically a rectangle that says mouse over me, so when the mouse is over, it will say, it will overwrite the text value of that div to be thank you. When the mouse is out, it will say mouse over me again. You also have on mouse down, on mouse up, and on click. As you can see, we define a div, and then we attach two event handlers calling on two different functions, m down and m up. So basically the div is a rectangle which just reads click me. When you click on it, when the mouse is done, it will say release me. When the mouse is up, it will say thank you. And then it just changes the color, the background color of the div. So you also have child nodes and node values. You can use child nodes and node values properties to get the contents of an element. The first child property is the same as using child nodes of index 0. Get element by ID is a method. Child nodes and node values are properties. So let's say that you define a p element with ID intro and text value hello world. If you say something like this, document.get elements by ID, and then you pass the ID, and then .child nodes of 0.node value, you can get the value of that element, or you can also use .firstChild.node value. So these are two different ways to get the value, the contents of an element. So this is about it for the very basics of DOM manipulation. Thank you very much. Hi and welcome. I'm going to be talking about DOM node relationships. So the nodes in the node tree have a hierarchical relationship to each other. The terms parent, child, and sibling are used to describe the relationships. Parent nodes have children. In a node tree, the top node is called the root or the root node. Every node has exactly one parent except the root, which has no parent. A node can have any number of children. Siblings are nodes with the same parent, brothers or sisters. So let's consider this HTML code on the right. On the left, we have kind of the relationship between the elements. So you have the root element, which is basically HTML, is the root element, and it is the parent node of the element head. Head, it is a next sibling to element. The previous sibling to body is head, and you can see that the first child of HTML is head, and the last child of HTML is body. The child nodes to HTML and siblings to each other, these are head and body. So for example, from that I have it here on the right. The HTML code. HTML has no parents. The parents of head and body is HTML. The parent of the text value hello world is the element p. HTML has two child nodes, head and body. Head has one child node, which is title. Title has one child node, text value DOM tutorial. H1 and P are siblings and child nodes of body. Head is the first child of HTML. Body is the last child of HTML. H1 is the first child of body. P is the last child of body. You can use parent node, first child, and last child to navigate in an HTML document structure. So let's start with something very simple. DOM root nodes, two special properties to allow access to the full document. You can use document element. You can have access to the full document. If you want access to the body of the document, you call document.body. So let's say that you have a P section, a P element, and then a div with a P element inside. So you can say document.body.innerHTML. That will output the text value of the whole body. So it will say hello world, and the DOM is useful. You can create also new nodes in the DOM tree. Let's say that you have a div and two p elements. So for example, this line will create a new p element. This line will add text to the p element, create a text node first. This line, para.append child node, it will append the text node to the p element. This line will find an existing element, and the last line will append the new element to an existing element. You can also remove elements. Again, if you have a div with two p elements, you will find the parent, and then you can find the child, and then you do parent.remove child, and then you pass the child. You will remove the node from the parent. You can also do it like this. First you find the child like this, and then you can use parent node property to find the parent. Child.parent node.remove child, and then you pass the child. You can also have a node list. So for example, if you have two p elements, and then you say get elements by tag name, it will return all the p elements, and then you have to, if you want to access the second element, you have to index x of 1 dot inner HTML. You can have access to that. It will print the DOM. Is very useful. The index always start at 0. You can also have the node list length. So for example, you have two p elements. If you call on get elements by tag name, you will get it like in an array. If you iterate over the elements return, you can say x of I dot inner HTML. You can get like that the elements in that node list. Well, that is about it for the DOM node relationships, parent, child. How can you insert a child? How you can remove a child? Thank you very much. Hi, I would like to mention the node properties and node methods available when dealing with the DOM tree. So for example, on the first one, so let's say for the node properties, you have a node list that is returned when you use child nodes. Child nodes contains the child nodes of the current node. First child, when you call on the property called first child is the first child of the node, or null if it has no children. Last child is the last child of this node, or null if it has no children. Next sibling node that immediately follows the one in the child nodes of the parent node, or null if no node. Parent node, the parent node of this node, or null of if no parent. All that are very useful properties of the node. So you also have previous sibling, which is the sibling node that immediately precedes this one in the child nodes array, or null if no node. We also have the node methods. You can use append child. You pass the new child, so adds new child to the document, inserting it as the last child of this node. You also have clone node with argument boolean deep, makes and returns a copy of the node on which it is called. Boolean has child nodes. This returns a boolean. Returns true if this node has one or more children, and false if it has none. Insert before with two arguments, inserts the node new child into the tree as a child of this node, and then returns the inserted node. Remove child, You specify the old child, removes all child from the child nodes of this node, replace child with 2 arguments, replaces old child with new child, and returns old child. Old child must be a child of this node. And there are also a few properties and methods for node list. Node list, it has the length property, which is the number of nodes in the node list, and node list methods, which is you can use item and index, returns the node at the specified index, or null if the index is out of bounds. So these are very useful properties and methods available for node list and node. When you are dealing with the DOM tree, all this is very, very important and very useful when removing, traversing the childs, or just reading the value of an element in the tree that you are examining. So that is it for the nodes, properties and methods, and the node list properties and methods. Thank you very much. Hi and welcome. This is JavaScript XML DOM. Let's start with something very simple. The XML DOM is a standard for how to get, change, add, or delete XML elements. XML DOM is a standard model for XML. It is a standard programming interface for XML, and it is platform and language independent. The XML DOM node properties and methods available. Let's say that X is a node object. The properties that you can use is node name, node value, parent node, child nodes, and attributes. And the methods available are get elements by tag name, append child, and remove child. There's also the node type property. If it is type 1, it is an element. If it is type 2, it is an attribute. Type 3, it is text. 8, comment. And 9, it is a document. Let's start with something, some simple examples that I have prepared. So on the right, I have 3 XML samples. So this is the very standard structure of an XML document. I have a CDs, and I have the node.xml. I have CD catalog.xml. It's just list a lot of CDs, different elements, and books.xml, only 4 books there. So to create an XML parser, for example, you can use the XML HTTP request to initiate a file request from a server. The request will go through different states and different status. So for example, it goes from 0 to 4. 4 means that the request finished and the response is ready, and the status 200, it means that everything went fine. Let's say that in your HTML you have a div with IDs to, from, and message. You can initiate the request like this, having saying window.xml HTTP requests. It will open the request, and then you can assign it to a variable. Or if you're using Internet Explorer 6 or 5, you have to use ActiveX object. You will open the request, and then you specify either a get or post request. The second parameter, it is the server location or the actual file that you want to get from a server. The third parameter is whether it is true or false, specifying an asynchronous connection. In this case is false. So once you send the request, it will not proceed until the response is ready. So you can parse the response like this. You will get it in the object, and then you say response XML, and then you store it in the XML document object. So it will parse the XML document into this object. So once you get that, you can call on get elements by tag name, and then you go to the specific element that you want to get, for example, to, from, and body, and then child node 0 node value. So this will get the first child in that XML document. and then it will get the different node values from there, and then you just simply store it into the different div elements, to, from, and message. You can also parse an XML string into an XML DOM object. Let's say that your XML is coming from a string, something like this. You can use the DOM parser. You say DOM parse, new DOM parser, and then assign it to a parser object, and then you specify parse from string, and the string is txt, and then you assign it to an XML document object. So if you're using Internet Explorer, something a little bit different applies. ActiveX object, and then you call on load XML and then txt. That way you will parse the whole string into different elements, in which you can call by tag name, to, from, and body. Just the same idea as the previous example. So let's say that you are looking at a city catalog.xml. You can initiate the request, send it. Once you get a response, you store it in the XML document object. Let's say that you want to traverse the cities. You basically let's go to the HTML. In the HTML, on load, you call display CD, which is going to display the very first CD. Basically these are text values for the title, artist, country, company, price, and year. You define two buttons, previous and next. When you click it, you will call on the display CD, and you will display the value that is currently defined for the I index, for the I variable. So display CD will display artist, title, year, like this. Get element by ID, show CD. It will store it into this div, and the div was defined down here. Div ID show CD. It will write it there. So this is the functions called next and previous. Basically we'll call on display CD. On the next it will increase the index, on previous it will decrease the index, and then it will just call on display CD. And this is how you will get the values from this from this object, XML object, and then you will store it into txt and then assign it to the div that you have defined called show CD. So you can access the nodes in three different ways: by using get elements by tag name, by looping through the node tree, by navigating the node tree using the node relationships. So for example, you can say x.get elements by tag name title. It will get all title elements under x node, or XML doc get elements by tag name title. It will get all the title elements in the XML document. There is also a function called load XML doc, which will load the whole document into a XML object, and then you can go and grab the tag name title, and then you can access the third title element like this in an index fashion. You can print all title elements. You load the file, the XML file, and then you get all the title elements, and then just loop through it using child nodes and then node value. You can also traverse the nodes using loading the document like this, and then grabbing document element dot child nodes, assign it to x, and then loop through x, all x dot length. It will traverse all the nodes, and then if the node type is 1, it means it is an element. You will access the node name. So this is the way how to write a simple XML parser. Thank you very much. let's go into this example about XML attributes. So if we have an XML that looks like this, a bookstore with 4 books, so the root node bookstore holds 4 book nodes. The first book node holds 4 nodes: title, author, year, and price, which contains 1 text node each: Everyday Italian, Giada De Laurentiis, 2005, 30. As you can see, the structure of the XML. So for the very first textbook, in the XML, the title element is the first child of the book element, and the price element is the last child of the book element. Furthermore, the book element is the parent node of the title, author, year, and price elements. So there's also node properties called node name, node value, and node type, which are very important. The node relationships, you have parent node, child nodes, first child, last child, next sibling, and previous sibling. So if you want to get the node values, you can use the function called getElementsByTagName, and then child nodes dot node value. If you want to change the node values, you can use the node value property and then just assign the new value. You can also change attributes using the node value. So in this example, you have the element, it is called book. The attribute is called category. So you can access the attributes like this. Get attribute node called category, and then you say again the same thing, node value. Then you can change the attribute name like this, the attribute value, I mean displayed values of category attribute. You get the attributes, and then you get name, item, category, node value. You will get cooking. So for that, if you were to retrieve it from the second book, you will get children, web for the third and fourth book. So this is very simple example on how to access the attributes, how to change the node values of the attributes, basic relationships between the nodes and the node properties, the structure of the XML, how it looks, the relationships that it holds between the nodes, the parent nodes and the child nodes, and the attributes, how you can display the node value like this, the attributes. And that is it about nodes, attributes, and relationships. Thank you. Hi and welcome. This example deals with how to add nodes to the XML3. So let's say that you create an element called edition, and then you get the elements by tag name book. So you go and get the very first book, and then to the very first book you append the child new element. The new element is called edition. So you will create a new element for the first book. You can create new attribute node in this way as well. Create attribute edition, and then you store the node value first. You get the element by tag name called title. So to that you're gonna say set attribute node new attribute. So you're gonna say edition first. So to the attribute edition, you set the node value first, and then you say set attribute node new attribute. So the edition value will be first. Create attribute using set attribute. You can use this function called set attribute to set the attribute as well, using the the same manner. And you can add text to a text node using insert data as well. You have to specify an offset and then the value. The index usually starts at 0. You can also create nodes like this. Let's say that you load the XML document, and then you create an element addition, creates the addition element, and then you create a text node with text first. You append new text node to the new element. You get the very first book, and then you append the child new element. Append the new element node to the first book element. You can use append child. You can also clone a node. You load the XML document. You get the very first book with get elements by tag name book index 0, and then you say old node.clone node true, and then you assign it to new node. You're basically making a copy of that node, and then you say xml.document element.append child new node. It will append that newly created node to the XML document element. And then you, if you want to output all the titles, you write a for loop, and you get the titles. You get the array with all the titles, and then you just loop through it. Y of I child nodes node value, and it will output Everyday Italian, Harry Potter, xQuery, Quick Start, Kickstart, Learning XML, and Everyday Italian. This is the clone node. This is another very simple example on how to clone nodes, how to create nodes, and how to add nodes to the XML tree. And that is it for today. Thank you very much. Hi and welcome. This example deals with how to remove nodes. So let's say that you want to remove a node from books.xml. Books.xml is here on the right. It only has 4 books. So let's say that you want to load the document, and then you want to get elements by tag name book. Then you get the very first book. You store it into Y. And then you say XML document element remove child. It will remove the first book element. Let's say that you want to remove the current node. If you're in a specific node, you would get, for example, the very first book. Let's say that that's the one that you want to remove. You can say x.parent node.remove child x. The parent node property and remove child methods are used to remove the current node. You want to remove a text node, same idea. You get the very first title, get elements by tag name title, and then index 0, and then you get the child nodes and store it into Y, and then from x.remove child Y, it will remove the text node. Because, for example, the title node has a child node, a text node, which is, for example, in this case, it is Everyday Italian. So in this case, when you're saying x.child nodes, it is getting the text node from this title element. And then when you're saying x.remove child while, it will remove the text node. You want to clear a text node, you get the very first title from the first book, and then you get the child node, and then you say the node value, it is empty. The quotes, it will clear the text of a node. If you want to remove an attribute node by name, you say get elements by tag name book, remove attribute, and then you say category. Remove the category attribute in the first book element. So you can see that the first element it is called book, and then you have an attribute called category. So that it will remove that attribute from that. If you want to remove an attribute, nodes by object, you can say it like this. You get the elements by tag name book. You will get all the books, and then you loop through it, and then it will you call on remove attributes node, and then the attribute node removes all attributes of all book elements. So it will remove the category attributes. Category, and in this case cover as well. So that is it for examples about deleting, removing nodes, text nodes, and attributes. Thank you very much. Hi and welcome. This example deals with how to replace nodes. So let's say that you want to replace an element node. You load the document element. Let's say that you want to first create a book element, title element, and a text node. So you say create element book, create element title, and create text node, a notebook. So you want to add the text node to the title node. So you will say new title.append child new text. You want to add the title node to the book node. You will say new node.append child new title, and then XML.get elements by tag name book. So you will get the very first book. Replace the first book node with a new node. So you will say x.replace child new name new node comma y. So you will replace the first book element. So let's say, for example, originally it was just Everyday Italian, Harry Potter, X Query, Kickstart, and Learning XML. After this code, the very first book, it will be a notebook, Harry Potter, X Query, Kickstart, and Learning XML. So this is a very simple example on how to replace a node. So this is on the right is the original XML file that it gets loaded. You create the element, you create a text node, and then you append it to the title node, and then you append it to the book node. Then you replace the child. So this is a very simple example on how to do replacement of a node. Thank you very much. Hi and welcome. This is JavaScript. We're going to be using regular expressions. A regular expression is an object that describes a pattern of characters. When you search in a text, you can use a pattern to describe what you are searching for. A simple pattern can be one single character as well. A more complicated pattern can consist of more characters and can be used for parsing, format checking, substitution, and more. Regular expressions are used to perform powerful pattern matching and search and replace functions on text. And this is the syntax. You use the regular exp constructor, and then you pass a pattern and modifiers, or you simply use a slash pattern slash modifiers. Pattern specifies the pattern of an expression, and modifiers specify if a search should be global, case sensitive, etc. Modifiers and brackets. Modifiers are used to perform case insensitive and global searches. You have modifier I for doing case insensitive matching, and G for global match, finds all matches, and multi-line matching. Brackets are used to find a range of characters. So in this way you can also use the caret to find characters or digits not between the brackets, and you can also use the parentheses to find any of the alternatives specified. And you also have meta characters. Meta characters are characters with a special meaning. You have the dot to find a single character. You have the \w to find a word character or a non-word character. You have as \d to find a digit or a non-digit character in the capital D. \s is to find white space character, and then capital S to find non-white space character. \b to find a match at the beginning or end of a word. Capital B to find a match not at the beginning or end of a word. You can also find a null character using \0 and \n to find a new line character, \f to find a foreign feed character. You can use \r to find a carriage return character, \t to find a tab character, b to find a vertical tab character, xxx to find a character specified by an octal number, xdd to find a character specified by a hexadecimal number dd, and uxxxx to find the Unicode character specified by a hexadecimal number. You also have quantifiers. N+ matches any string that contains at least one n. N* matches any string that contains 0 or more occurrences of n. N question mark matches any string that contains 0 or more occurrences of n. N curly braces x matches any string that contains a sequence of x n's. N curly brace x, y matches any string that contains a sequence of x to y n's. N curly braces x, matches any string that contains a sequence of at least x n's. And $sign matches any string with n at the end of it. Caret n matches any string with n at the beginning of it. This is very important. Caret is to signify the beginning of the string, $signs to signify the end of the string. Question mark equal n matches any string that is followed by a specific string n. Question mark exclamation mark n matches any string that is not followed by a specific string n. You have the regexp object properties and methods. For the property, you have the constructor returns the function that created the regular expression object's prototype. Global specifies if the G modifier is set. Ignore case specifies if the I modifier is set. Last index specifies the index at which to start the next match. Multi-line specifies if the N modifier is set. Source returns the text of the regular expression pattern. You have 4 methods available. Compile compiles a regular expression. Exec test for a match in a string returns the first match. Test it tests for a match string returns true or false. ToString returns the string value of the regular expression. Let's start with some basic examples that I have prepared. I have 7 examples. So the first example with performing a case insensitive and global matching for iPhone. For the word iPhone. So the string is develop iPhone and iPad applications. You construct the pattern as /iPhone/i, and then you want to retrieve the result by doing a string.match pattern1, and then you just output the result. In the HTML, I have a p element with ID demo, which is where I will write the result. So we can see that it returns an array with iPhone index 8, which is where it was find the first occurrence, the starting index, and then the input provided. Example number 2 deals with a global search for is. The string is this all there is. The pattern you constructed as /is/g, and then you retrieve the results like this: string.match pattern1, and then you print the output, and then it returns 2 matches on that string. So now let's go to example number 3, is doing a global case insensitive search for IS. Let's see the difference. Is this all there is? That's the string pattern is with modifiers GI. You do the same thing, so let's see the result for that. It returns three matches like this. So that is it for a very basic introduction to regular expressions. Thank you very much. Hi, this section deals with the methods available for regular expressions. In example number 4, we're going to be searching a string for a character E using the test method. The test method, it tests for a match. It returns true or false. So we're going to be looking for the pattern E in the string provided. The best things in life are free. Let's see what it prints out. So it's true. It went into the string and looked for that pattern. So example number 5 deals with searching a string for the character E using exec. So it's very similar to test, but the difference is that it returns the first match. This is the same string. So for example number 5, it returns an array with the pattern that you are searching for, the index where the pattern was found for the first match, and the input string. And then let's see the two string methods available. So let's say that you want to search the pattern hello world and then do a global search. And then you do pattern dot to a string. So this will return the string value of the regular expression. And then I'm just going to print to the p element called with ID demo defined in the HTML here. And you can see the string representation. So that is pretty much it for the three methods available for the regular expression. There is a fourth method called compile, but it is now deprecated. And these are the 3 methods that you are going to be using most of the time. Thank you very much. Hi, this is example number 7 and deals with constructing regular expressions to match a string. So for example, this one is example number 7 is to parse a number. We construct the regular expression like this. We give the pattern and then the modifier, case insensitive. This is the pattern that is going to match the string against. So for example, at the beginning and end, we can enclose the string like this to be matched all the characters against this. So the parenthesis mark capturing group, and then the question mark makes the given pattern to be optional. It makes it optional. So for example, in the first one, we have the caret and then ending with the $sign. Tells if the string contains only a number. If you have minus question mark, it is an optional minus sign. \d plus, it matches 1 or more digits. And this other group, it is a decimal point followed by 0 or more digits. This other group, it matches E or a capital E. It has an optional sign and 1 or more digits. And then we're gonna create this function called test and then pass a parameter to test, and then we're gonna use the function parse number.test. We're gonna use the regular expression, and then we're gonna test the argument given. So for example, if you say test1, that is gonna return true. it will say test number, that is a string, is not gonna match against, that is not a number, returns false. 98.6 returns true. If we give something that is made up of numbers, but in like an IP address fashion, it will say false. If you give exponential notation, capital E minus 67, is gonna match that capital E, the optional sign, and then one or more digits, so it will return true. And then at the end, if you put in a D, that is not a number, a valid number, and it's gonna return false. The next example, it is example number 8. It is an example of how to parse a URL. It is made of several different groups. So let's say that you want to parse the URL http ://learntoprogram.tv port 80 /course !Q sharp sign JavaScript. Let's say that you construct the regular expression parse URL like this. It has many groups that is gonna match against, so it's gonna go kind of section by section. So let's say at the beginning we have the caret, it marks the beginning of the string. We have this group, it is an optional group, it matches the scheme name followed by colon. Now we have this group is gonna match the slash. The slash will be matched 0, 1, 2 or 3 times, and then we're gonna match the host name with which is made of digits, letters, a point or a negative sign like this. You match like this. You give the range of characters that are possible to be there. You have to escape the negative sign like this, backslash. That's the way to escape this character. The next group you want to matches a port number, \d plus, that matches optionally matches a port number. The next group, it optionally matches all characters except question mark or the sharp sign like this. So if it is there, it matches. If it is not there, then it doesn't match. It doesn't return anything for this. So the next group, it is optionally matching one or more characters that are not the sharp sign. The next group is going to optionally match to begin with a sharp sign. It will match any characters except line ending characters, and then at the end the $sign signifies the end of the string, so it will match all the characters in the string against the regular expression. So let's say we have the parse URL like this, constructed like this. And then we are declaring the URL http learntoprogram.tv port 80 course Q JavaScript. So we're gonna parse the URL, exec URL, and then store it in result. We declare the names array, URL scheme / host port path query and hash. So now we print the array names and then the result. So we see for the URL it returned the originally the URL provided. The scheme, it is returned as HTTP. The slash, it is matched as 2 slashes. For host, it matched learntoprogram.tv. The port, it matched 80. The path, it matched course. And the query, it returned Q. And then the hash, it is JavaScript. So this is a very simple example on how to construct regular expressions and match it against a string. Many times you have to match, extract tokens from a URL, writing regular expressions. This is very useful. You can declare capturing groups, non-capturing groups. Non-capturing it is an optional group. You can use the curly braces to signify repetition. You can use brackets to signify a range of characters or digits. You use the star to signify one or more, the plus signs to signify 0 or more. Question mark makes it optional. So this is very simple examples about regular expressions. Thank you very much.
Hi and welcome. This is JavaScript. We're gonna be talking about the window object. Let's start with something very simple. Browser object model, BOM. The BOM allows JavaScript to talk to the browser. The window object is supported by all browsers. It represents the browser's window. All global JavaScript objects, functions, and variables automatically become members of the window object. Global variables are properties of the window object. Global functions are methods of the window object. Window size. There are 3 different properties that can be used to determine the size of the browser window. For Internet Explorer, Chrome, Firefox, Opera, and Safari, you can use window.innerHeight to get the inner height of the browser window. Window.innerWidth to get the inner width of the browser window. For Internet Explorer 5 to 8, you can use document.documentElement.clientHeight, document.documentElement.clientWidth, or document.body.clientHeight and document.body.clientWidth. These are other window methods available. Window.open to open a new window. Window.close to close the current window. Window.move to move the current window, and window.resize to resize the current window. Window screen and location. The window.screen object contains information about the user's screen. Some properties available: screen.availWidth to get the available screen width, screen.availHeight to get the available screen height. Window.location can be used to get the current page address or the URL and to redirect the browser to a new page. Some other properties for location: location.hostname returns the domain name of the web host. Location.pathname returns the path and file name of the current page. Location.port returns the port of the web host, either 80 or 443. Location.protocol returns the web protocol used, HTTP or HTTPS. Window properties and methods. Location.href, this is a property that returns the URL of the current page. Location.assigns, this method loads a new document. Window.history, this is an object that contains the browser's history. To protect the privacy of the users, there's a limitation of how JavaScript can access this object. History.back is the same as clicking back in the browser. History.forward is the same as clicking forward in the browser. The JavaScript window navigator properties. A window.navigator object contains information about the visitor's browser. Navigator.app code name is the browser code name. Navigator.app name is the browser name. Navigator.app version is the browser version. Navigator.cookie enable it tells you whether cookie is enabled. Navigator.platform is the platform. .user agent is the user agent header, and .system language is the user agent language. And there are some pop-up boxes that are also available. JavaScript has 3 kinds of pop-up boxes: alert box, confirm box, and prompt box. The alert box is used to make sure information comes through the user. You can specify like window.alert and then some text, or just alerts and then some text. The confirm box is if you want the user to verify or accept something. When a confirm box appears, the user will have to either OK or cancel to proceed. You can use it as window.confirm and then some text. And then the prompt box is used if you want the user to input that value before entering a page. window.prompt, then some text or the default text. You can also use line breaks in the alert box. To display line breaks inside a pop-up box, use a backslash followed by backslash n followed by the rest of the text. Alert, how are you? You can display it in two different lines. There are also JavaScript timing events related to the window object. It is possible to execute code in time intervals. This is called timing events. The two key methods used are setInterval. It executes a function over and over again at specified time intervals. setTimeout executes a function once after waiting a specified number of milliseconds. So how to stop execution? If you want to stop execution, you can do window.clearInterval. It's used to stop further executions of the function specified in the setInterval method. Window.clearTimeout is used to stop the execution of the function specified in the setTimeout method. There are also JavaScript cookies. A cookie is a variable that is stored in the visitor's computer. Each time the visitor requests a page with the browser, it will send the cookie to. Examples of a cookie can be the name cookie. The first time a visitor arrives at your web page, he or she must fill in the name. The name is then stored in a cookie. The date cookie. The first time a visitor arrives at your web page, the current date, it is stored in a cookie. So this is the very simple introduction to the window object. Thank you very much. Hi and welcome. This is example deals with the window object and how to retrieve and read specific properties that are important to know. In example number 1, we are trying to get the width of the screen and the height, and then also print out the screen dot available width, available height, the location dot href and the location path. So if we just execute example number 1, we see that it prints browser inner window width 548, height 232, and then on the log we print out the available width and height. So the current size of the window is 548 by 232, and the total available width and height of the browser window is 1366 and 728. And then if we print location.href, it's gonna print the current URL. So this is the location of this HTML file, and then the path name, it returns basically the same thing as href. For example number 2, this example deals with window.navigator. So we just print out this. We see the browser code name, the browser name, version, whether cookies are enabled or not for this browser, the platform, the user agent header and language, and then we just put it in the div called example. This is the HTML define. We define some buttons for calling on the examples. We define a on-click event function, my stop function for another example. Some other buttons to call on new dog, go back, go forward, and we have two IDs, the div with ID example and p element with ID demo, and it's going to be referencing window.js. So on this time we print out all these. It is Mozilla code name, the browser name Netscape, the browser version 5.0, cookies enabled true, platform Win32, the header is Mozilla 5.0, it's actually Chrome 28, and then user agent language is undefined. So these are very important properties to know about the window object, window navigator, and then location, window location, and the screen width and height. This is about it, these two examples. Thank you very much. Hi and welcome. These examples deals with window.history. We have back and forward, so I'm going to be showing the functionality of this. And I'm also trying to print to the log the window history. So before coming to this HTML, I went to some sites. So let's see. Now if I click on back, it jumps to the previous URL, learn to program.tv. So the browser has these back and forward buttons. So forward on the previous page, it brings you to the current window is window.html. If I go forward, it's gonna go to ebay.com, because previously before coming to window.html, I went to learn to program.tv. From there, I went to window.html. From window.html, then I went to ebay.com. So the history starts building up so that it knows where to go whenever you click on these buttons. Otherwise, the history is undefined and it's not going to do anything. For the window.location.assign, it's gonna load another document. So if you wanna redirect to a different page, you can use .assign. So load new document is gonna go to learn to program.tv. So these are two very important methods available for the history, back and forward. Let's see if okay, so that's back and forward. There's another, this is example number 3 now, about pop-up boxes. So let's see if we print example number 3. It says I am an alert box. So this is one type of pop-up boxes, alert. You also have confirm, which is going to say press a button, and then whether you press OK or cancel on that window, it will say you press such and such. And then you can also have a prompt, please enter your name, and then the default text is set to Harry Potter, and then it will check on that and then just print it out. So first we have I am an alert box from here. So let's say we click on OK. So now we get the confirm window, press a button, so it only has OK or cancel. If I press on OK, it's gonna show here ID document.getElement by ID demo.inner HTML. It gets assigned the value of X. The value of X is you pressed OK and gets written to the document. So next one is a prompt, and it's gonna be assigned to person. Please enter your name. The default text is Harry Potter, so let's say I enter my name, and then it writes again to the div called demo. Hello Marco, how are you today? So this is very simple examples about pop-up boxes and the history on the browser and how to redirect to a different page. Thank you very much. Hi and welcome. These are examples that deal with timing events, set interval, and set timeout. Set interval just keeps repeating the same function over and over. You give it an action and then like an interval. So every 3 seconds it's gonna call an alert and then display hello. For example number 4. For example number 5. This is a digital clock that is gonna set at the interval of 1 second. So every second is gonna call on my timer and it's gonna update my timer. every second. So if you want to stop either the interval or the timeout, I define a function called my stop function. It's actually defined twice. It's gonna be coming here, and it's gonna do clear interval my bar, clear timeout my bar. My bar is defined globally like this, as a set interval, for example number 4 and 5. And then I will go to a set timeout example. Set timeout is basically the same thing, but it just gets called once instead of infinite loop. So it will call example number 4, calls hello, and then it's gonna call it again. If we want to stop it, we click on the stop time. It's gonna clear the interval. So how about example number 5? Example number 5, we see this starts counting, it starts displaying the digital clock. It's going to update the div called demo. We can also stop it by saying stop time is gonna clear interval my bar. My bar is called, it is set as set interval my function my timer every 1 second, so that gets stopped with that. And I also have one more example for set timeout. This is a function that only gets called once. Let's see the output from example number 6. So it brings up the alert box saying hello. And it's only called once instead of repetitive times in set interval. So this is very basic examples about set interval, set timeout, and the parameters that it's using, and then how you can use them to your advantage to set a specific timer to perform a specific task every set interval. It is very useful. So that is it for today. Thank you very much.